Okay, welcome everyone. So today we are going to look at mechanics as I promised. So we talked about forces before and we covered enough work there. The work that was covered, it was basically basics on forces. And if you understand the basics, you can do further topics in forces. So for today, I really want to talk about motion because I've received a lot of concerns. People want to learn projectile motion. But of course, before we go into the details of motion, let's first see what the syllabus wants you to know as far as mechanics is concerned. Because I'm going to teach some things which are not in the book, but you need them. So I need to alert you early enough so that you know why we are doing what we are going to do. Okay. Now, the math syllabus book is there. So as you can see, in senior 6 term 2, hope you're seeing my screen. The voice is clear and everything. So senior 6 term 2, we have topic 20, and topic 20 is dynamics 2. So dynamics 2 has has only and only 3 subtopics. You get? So the first subtopic being resultant velocity, the next one being relative motion, and the third being projectile motion. So don't be surprised when I cover projectile motion first before these ones. Don't be surprised. It is possible and it can happen. It's not a must. It's not a must that the first two must come before projectile, no? We can handle projectile, then the other ones come later. You get the point? But before we cover dynamics 1, so before we cover dynamics 2, that means there is what we call dynamics 1. And I think dynamics 1, I think it is topic 8 and it is a senior 5 topic, term 1. It's topic 8, if I'm not mistaken. Yeah, it's here. So you can see this is senior 5, term 2. Remember the other one is dynamics 2. So you should ask yourself what of this. So scatter diagrams and correlations, those ones you are aware that we completed them. Yeah, and we have them on the drive. So concerning topic 8, which is our dynamics 1 in senior 5 term 2, the very first thing you're supposed to cover is what? Components and resultant of the force. That's the subtopic 1 under topic 8 dynamics 1. And you know where to find this. We have this. So the other things we've not done yet, it is Newton's laws of motion and friction, then connected particles, which you're also covering soon. So those who will listen to this in the future, you never know. Those lessons will be in existence, so no need to worry. But the current people right now, you should be worried that we have not done that, but we are going to do it. So it's a senior 5 term 2 topic, and it is topic 8. And that is all for dynamics 1. You should be aware. That is all for dynamics 1. There is nothing else. So someone has sent me a private message that I should show it to them. Okay, the direction is simple. When you go to the principal math folder, you go to senior 5. We have said term 2, then topic 8. I think you can see topic 8 is dynamics 1. So dynamics 1, that's where you can find resultant and components of a force. And that lesson is there, as you can see. Hope you get my point. Then the other ones, that is friction and connected particles, the ones we've not yet covered. So for today's lesson, we are introducing dynamics 2. So if you really want to access this recording after the class, you're supposed to go to that folder of senior 6 term 2, the very first topic 20, which is dynamics 2. But we are beginning with the third subtopic, which is projectile motion. Okay, I think that is clear. Where are we? We are here. Okay, so that is it. I've briefed you about dynamics 1, and I've given you the plan of dynamics 1. So I can go back to dynamics 2, that is topic 20. And we have agreed relative velocity. In most cases, relative velocity goes hand in hand with relative motion. As you can see, this one, they are talking of resultant velocity. Here we are having relative velocity. You get? So they have some bit of connection. It is better to cover resultant first and immediately you cover relative. But projectile can come before or after them. And this is my interest today. So I'm going to have a bigger screen for projectile motion so that we begin our session. Okay. I think Flash has something to say. Yes, Flash.
Yes, excuse me, sir. I'm asking about the lesson of connected particles. You have said that you haven't yet studied it,
Yes, it's going to be this holiday.
but is the video there already recorded?
Not yet.
Okay, sir.
Okay, boss.
But sir, I'm asking about. I've seen in the drives we don't have some notes for some subjects.
Oh, we are going to resolve that after here. Don't worry. If
All
it's
right.
not, that is easy. If it is videos, I put some and leave some blank because I want us to cover them lively, as you also cover those already recorded. But for notes, we are going to upload. Don't worry. Those ones are easy. Okay, thank you. So when you look at what the syllabus wants you to learn as far as projectile motion is concerned, they want you to resolve terms in projectile motion. Things like range, things like maximum height, things like time of flight, things like maximum range. They want you to review equations of motion. I want you people to look at this. Are you seeing part B? Remember in dynamics 1, you never looked at motion. Okay, we have somewhere Newton's laws of motion and friction. But literally, Newton's laws may not take on all the equations of linear motion. Even when I try to take you back a bit, you see, you're supposed to understand the syllabus. Don't just cover things anyhowly. So just briefly back here, I think this. We have friction, limiting equilibrium, equations of motion, and Newton's laws. And then after they want immediately the application of friction. So basically under this topic, they concentrate on friction. But we are supposed to cover some sorts of motion before we go into projectile. So if you make a very big mistake and just cover projectile motion through right away, you cannot understand. Because even under the very first topics, its coverage was not so clear. And then out of the blue, you are asked to review. So that means you're supposed to wiseacre as a student who really wants to pass. And I'm going to show you how we are wiseacring. This is what we are going to do. So, you're going to bear with me. Have it in mind, you cannot understand projectile motion unless you know linear motion. Let me repeat. You cannot understand projectile motion unless you know linear motion. So the very first thing we are going to cover today is going to be linear motion. Yeah. And when you look at what really the syllabus wanted, it wanted projectiles in vertical and horizontal but at an angle. So they also wanted at an angle. So literally for projectiles, before we cover them, you're going to allow me for today to cover linear motion only. So we are going to be here briefly. Only linear motion. Go and practice. We cannot start resolving these terms before you look at the most obvious terms that begin the topic of motion. So allow me cover linear motion as a topic today. Then next time, this part of resolution is easy because I taught you. So if you want to review resolution, you simply go back to that video of forces. We shall resolve these things the same way. So today it's linear motion. Because before we cover projectile, we should know it. So today it is strictly what? Linear motion and how you're going to review those things. So the next lesson we shall have, it will be on projectile motion, where we shall talk about vertical projection, where we shall talk about horizontal projection, and also talk about an angle, projecting things at an angle. So it will be easy for us. So hope people have understood why I want to teach linear motion for today, and then other things will follow. Okay. So I've told you that basically motion has motion in a straight line. So we are going to cover basics, motion in a straight line. Then we are also going to cover projectile motion. Yeah. But I would want to separate something here that we shall also talk about vertical projection. And I'll tell you what all these ones mean. Vertical projection. So for projectile motion, we shall talk about the part of horizontal projection. Shouldn't forget. And I also teach you oblique projection. So when we get done with that, you'll be a very good student of motion. Then maybe later on, you add on what? Resultant motion. Sorry, relative motion. After covering resultant velocity. Okay, so for today, I've said what we are going to cover is strictly and strictly motion in a straight line. So motion in a straight line, this is today. Motion in a straight line, we are doing this today. And motion in a straight line, it's what they call linear motion. Motion in a straight line is what we call linear what? Linear motion. Yeah. So this is what we are doing today only. So the next time we shall be back, most of the basics shall have been talked about. We shall do vertical projection. I will have a lesson with that vertical projection, and I'll take you slowly because most of you have issues here. So vertical projection, I can also decide it to be a lesson, or maybe I can combine it with horizontal. Then next time we only do oblique. Yes, I can decide to combine vertical projection and horizontal projection, and maybe we resolve sometime. Then oblique projection, I also want it to be a specific lesson, special one, but we shall see what time has for us. So for today, allow me cover linear motion. So since most of you have issues with projectile, make sure you understand basics. Those who know everything, you can now, that the decision is in your hands. Either stay on and listen, you in form of revision, or you keep around. So I've told you that linear motion, because of the word linear, it is motion in a straight what? Straight line. Linear. Linear alone for straight line. So this is straight line motion. So for you to understand this linear motion very well so that you can attempt whichever question that comes across, you're supposed to resolve the following terms. If you can define these terms correctly, you're good to go. Okay, so let me give you those terms here. If you can resolve these terms, you're good to go. So I'll say terms involved. That these are the terms involved in linear motion. So when we resolve them, you're going to just enjoy. So let me first list all of them. So we are going to begin with distance. Displacement. Shall talk about time briefly. Then we have speed. We have velocity. Average speed. Average velocity. We have acceleration. Which acceleration can be a constant. Or if people sometimes don't use uniform acceleration, they use constant. Yeah. One word is older, the other is modern. So basically, those are the terms that you need. And if you're here and you're well conversant with all of them, that means you're that person who can handle most of the questions in this topic. Displacement, distance, speed, velocity, average speed and average velocity. We are going to see all this. And if you can handle acceleration, the uniform or the constant, then we derive the equations of motion. We shall be good to go. Basically that. And I want to leave you with some numbers. You practice them immediately after here, such that I can even fix a lesson in the evening and say you come online again, we cover vertical motion for just 1.5 hours or 2 hours, and then we meet again at night. So it will depend on whether you people are compliant. So those will be enough. So let's resolve them one by one so that if they are used in the future, no word confuses you at all. Okay, now, let me use the next page. Let us first save our document. So you've heard of those words of distance. You've had them before. Yeah, I don't think any word is new. So today it's linear motion strictly. Okay. So we are going to assume we have two fixed points. Yes, assume we have two fixed points. That is A and B. Yes, 2 points, A and B. Assume that's what we have. A can be a school, B can be a church, A can be a toilet, B can be a mall, A can be a road, B can be a mosque, anything. So, if you're having your point A here, fixed points, you're also having your B here, fixed point. So we have that length. And I'm going to come and let you know that the length between A and B is what they call distance. No one is going to ask you to define these things in math. No one. Just understand what they mean. So if you are having two fixed points, point A and point B, the distance is that length between those two fixed points. So from today onwards, define distance as what? The length between two fixed points, period, period. Don't add on anything else. So distance, we are done. So I'm going to come and tick. The moment I tick all, the next thing shall be deriving equations of motion, and the last thing shall be calculating, and the very last one shall be assignment. Cut. I want you to recap this. This is something you covered in O level, but I just want to see if people recall. Who can give us the distinction between scalar and vector quantities? So the very first thing, you're supposed to look at the distinction between scalar and vector quantities. And I want someone who is going to give me two examples in each case. And I want you to give me sister examples. And I think I also taught you this in forces. Remember teaching you. Yes, Fifi? Unmute and say something.
Scalar quantities, these are quantities with only magnitude and which is stroked with the size, magnitude, stroke size. Examples, we have mass and distance. Then vector quantities, these are quantities with both magnitude and direction. Examples, we have velocity and displacement. That's it.
Yes, that is very good. Taking a mobile, please leave our screen. Yes, that is very good. I think you've said it all. That's what I wanted. That's what I wanted. You've defined things well, and Okay. Okay, our friend has told us that for scalar quantities, she has said have only magnitude. That is the modern word, but the ancient word is size. They have only size. That's what she first told us. Then she added and said, for vector quantities, these ones basically have both magnitude or size and direction. Very important. Direction. So what is the similarity? Both of them have what? Magnitude. What is the difference? For vector quantities, they have a direction that is specific. Yes, so when you find specific direction, don't be like, I thought you just said direction. It's the same thing. Don't just give it time. Okay, now, what are those examples? Here she said time. The scalar ones are basically three: time, mass, we have length. Remember, distance is length. So those three, basically those. There are others, there are so many, but for now, what I want to explain will only require me to have that. So, I've told you that the length, distance. So those three fundamental quantities, they are scalar ones. So, when we talk of time, you always just set 2 seconds and you don't add anything else. 2 seconds, it's enough. When it's mass, you always just set 2 kilograms. You don't add on anything. That's why even in chemistry, always just say maybe 120 grams. Don't add on anything because we only have size as scalar quantities. Even length and distance, you always just say 20 kilometers. You don't add on anything. Get the point? We always just say 5 centimeters without adding anything else. Why? We just have size, or what we call magnitude. We don't have a specific direction. Then for vector quantities, you all know that vectors mean direction. Those of you who attended to our classes on vectors, you know what I mean. That with vectors, please people, leave the screen, be disciplined. Just simply look at your phone and follow, leave other things. So, what do I mean here? For example, she gave us an example of velocity, she gave us displacement. So, how are these things written? How are these things written? Because you may not know what the direction is, but you people very well know that so this was the example. So even these ones are going to be our examples. So she gave us an example of displacement. So how do you write this displacement? For you to say that something has been displaced, you mention the directions. In most of the cases, the word displacement alone is clear. It is very clear that you're displacing something from one point to the next. So there is need for you to mention the direction. And you need to know that distance is the sister to displacement. Just because distance is scalar and displacement is a vector quantity. So every time you're talking of displacement, it is supposed to be a distance. Maybe be like 20 kilometers from A to B. Why we are saying from A to B, we are trying to bring out the point of view specifying the direction. This A can be any town. It can be maybe Masaka. And then this one is some other place. Maybe Chira. Be like from Masaka to Chira, the distance is that. So every time you come out to specify the direction, that becomes displacement, provided you specify the direction of motion, it becomes displacement, but they can have the same magnitude. So that's what they call specifying direction. Yes. They may not use those words of A and B and so on and so forth. They can just say, please and please consider 5 centimeters to the left. So the moment they say to the left, when you see this one is a distance, but it is a distance in a specified direction, so it becomes displacement. So 5 centimeters alone is a length. Let's assume these are 5 centimeters between 2 points. And we said length between 2 fixed points is a distance. But the moment you mix it with a direction, it becomes displacement. That's a direction. To the left is the specific direction. So in summary, the moment you move a certain distance in a specified direction, that becomes displacement. Yes. Yes. This can be a building. This can be a building. And they tell you, this one, they tell you that from down to up, then from up to down, like that. They tell you, yeah, these ones are 4 meters. Then they tell you, yeah, these ones are -4 meters. Because that's what they want. They may even interchange and say the first one is the -4, this one is the +4. But what am I trying to show you here? That the moment they start specifying direction for distance, that one becomes displacement. You get? So this negative was showing what? Direction. Maybe someone is here and they are going to project a body. I will teach you that. You learn that distance we have below the building is a negative. And the mere fact that we have given it a negative, that is direction. So a combination of direction and this value 4. This value 4 is the distance. So these two, they make up a what? A displacement. So I've explained that and I'm not repeating. Yeah. Hope we are together there. So the same case with velocity. So when you're talking of velocity, you should respect that. Velocity is a vector quantity. Then the sister of velocity is speed. But for the case of speed, speed is scalar. Yeah. Hope you are aware. Speed is scalar. That means for speed, you just say that my speed is 1 meter per second. That is speed. Don't add on anything else. But for velocity, which is a vector quantity, you're free to come and say, I was traveling at a speed of negative what? 5 meters per second. The moment, now the 5 meters per second is the speed. This negative is showing direction, so it becomes velocity. because it's a vector quantity. When you say that I was traveling at a speed of 10 meters per second, like that is the speed. But the moment you add on direction, maybe say to the left, even if you don't say to the left, maybe you're showing direction in terms of angles, and maybe you say at an angle, blah blah blah. You've seen these words before, I don't want to complete. So the moment you say at an angle, all of you know, I told you that in forces, that when they ask the magnitude and direction of the resultant force, the direction is written in terms of an angle, maybe with the horizontal or the vertical, or you can use bearing. So the moment you start an angle, that is being a specific direction. If they don't, something like that. So when you see those things, that is direction. So note, you can be given compass directions, but that one is very clear. The mere fact that they are directions is enough to show you that when they appear anywhere, that is a vector quantity. So direction, they can tell you north, they can tell you east. When you see them anywhere, that is direction, so things are rendered to be what? Vector quantities. If they don't use those 4 cardinal points, they can bring the secondary ones. They can tell you north, 30 degrees west. They can say northeast and etc. You know them. So when you see that, those are being specific directions. So immediately treat that something as a vector quantity. I don't want to oversay much about it. So for vector and scalar, I'm done. Remember, we were supposed to resolve the definition of displacement. But now I believe people are aware that displacement is simply a distance you're moving in a specified direction. Nothing much. The displacement is a distance you're moving in a specified direction. Which direction can be a negative or positive, a left or a right, up or down, northwest or northeast, and some other things. Okay, now, what of speed? So let's go and tick. Displacement. I told you when you resolve the terms perfectly, the lesson will be done. So in the future lessons involving motion, because realize every topic we are remaining with has motion. Even connected particles, the topic is called motion of connected particles. Even Newton's laws, it is Newton's laws of motion. There is friction. You know, friction comes in motion. When something is moving, then friction comes in to resist the movement. Then relative motion, but you know, before relative motion, we study resultant velocity, which has motion in it. So for you to understand resultant velocity, you should know speed, you should know velocity, you should know average velocity and average speed. So you give this lesson time, understand the basics. When they are used in the future, you don't have that burden of understanding the basic work. So follow strictly. We proceed. Displacement tick, because it is a distance in a specified direction. Then the time, that one is easier. After time, it is speed and velocity. Let me talk about time briefly. So you all know time. Time is basically measured in seconds. Time is, let me show you how simple things can be had. Who can define for us time? You may end up saying it is the time taken to cover something. Who can define for me time? Yes, you can be asked that in a symposium or an international quiz. Yes, Bered. Bered, define for us time.
Yeah, to me, I think time is the duration of an activity.
Thank you so much. You went to a very good primary school. Any other definition different from that you can share with us? Okay, the last one, just us. Do you have a different definition?
Yeah, that time is a scalar quantity that measures
Mm.
intervals between events.
That is very good. That is very good. That is very good. So it's basically measuring duration. Yeah. Yeah, time. This one is a fundamental physical quantity that measures duration. Yeah, I think it was set in physics. I think it was 1987. And so many people failed because they were saying time is the time taken. Okay. So this one measures strictly duration. Only that, duration is enough. Yeah. So the duration can either be of an event, maybe how long menstruation takes, how long sleep takes. That's the duration of an event. Sleep is the event, or menstruation is the event. Or it can be the duration between two intervals, maybe that. Measuring the interval between them. Maybe you want to know what is that time between dawn and dusk. What is that time between day and time? Something like that. Or an event. You don't need to over-reason. So that one strictly measures duration, as we've said. And you all know that the SI unit, someone may be like, but you're not talking about SI units. By the way, you're very right. SI units for distance, they are meters. So you're going to note that if I didn't. Yeah. So someone may be like, why are you giving them time? That's what the syllabus said, that SI units are very key. Failure to have SI units, you will fail. Physics students know what I mean. So SI unit, that we usually use here, meters. We are going to concentrate on meters. Meters for distance. Yeah. Then for time, the duration is always in seconds in most of the cases. Remember telling you seconds, it is just small s. So these seconds are the SI units. But you need to know they can provide things in minutes and so on and so forth. Yeah. So in case of minutes, you should know what to do. That 1 minute has 60 seconds. Then you should know that 1 hour has 60 minutes. That means 1 hour has 3600 seconds. They're things we know from primary. So I may not waste a lot of time here. 1 minute, 60 seconds, an hour, 60 minutes. So 60 times 60 will give us the seconds in an hour. Hope you know that. So concerning the change of units, just put that in consideration. Okay, so that is time. Basically, duration between events. Ig. Now back to distance. Ig. Ig, time taken. Time taken to move. Time taken to move from A to what? From A to B. Yes, that is it. Time taken to move from A to B. It can be like that. So it can be that measure of duration between intervals. Yeah. Okay, now after that, the other thing I want to tell you still concerning time is that when you're having this point A, you're having point B, you're having point C. I want you to listen. When you're moving from Okay. You're having the time taken to move from A to B. You get? Make you good students of motion. So from A to B, what we have there is what we call time taken to move from A to B. So that time taken to move from A to B is what they call small t AB, like that. So I'll not be wasting my time and writing for statements. When I do something like that, I mean time moving from A to B, time taken. Then if you're moving from here up to here, there is a term I'm introducing. We also have time taken to move from B to C. So that time will be T, B, C, like that. Don't be like, but you're teaching us very easy things. You start at numbers. I know that, but we have time and you're still Form 5s. Hey, you wait for next year to be a candidate. So, and this work will be needed by your friends who will be learning things from scratch. So you stay on and enjoy, or you wait when we start calculating. We catch it as you calculate. So if you know these things, the numbers I'm about to post, when I post the number, first do it. Then you see what I'm going to do. I tell you where your marks are and see if you have all the marks. And trust me, when you get all these things, projectile motion is going to become easy. Let's do linear, slowly. Let's do vertical projection, that is motion under gravity and against gravity. Yeah. Then we shall go to projectile and we shall be done. So we shall have half of dynamics 1, half of dynamics 2. Just 1 week into the holiday. So trust me, by the time January ends, we shall be done with most of the things. Yeah. Now, what is the thing I want to talk about? A combination. Hey, you listen. This is very important. A combination of TAB, and TBC is called, who can tell me, how is it called? I see freely you know these things you're calling simple. So that person is saying that these things are very simple. What is the name of that? A combination of TAB and TBC. How is it called? How is it called? I'm talking to that person saying that these things are easy. Okay, the combination of those two is what they call the total time taken. Yeah. And we shall also use it so much. So that's all about time. Those who want to take the screenshots, you can take. Yeah. Those who are forcing me to increase the speed, I will not. You're saying these things are easy, but there are people who will need them. Every time the speed doesn't favor you, that means you're supposed to depend on recordings. And when you're watching the recording, you increase the speed to times 1.25, 1.5, times 2, times 3, times 4. Yeah. So I think you're done with the screenshot, and that's all I wanted to say about time. Okay. So then speed and velocity. So for speed, I'm going to talk about it in a reverse way. Yeah, I will not say a lot of things. So concerning speed, you all know it is measured in meters per second. Why the reverse? Because we have talked about both units. So speed is measured in meters per second. So this meters per second can be written as meters per what? Per second, like that. Okay, now that means if you're having meters, that means if you're having meters per second, this one is meters per second. So the meters, this one measures distance, meters measure distance, and then the seconds, these ones measure time. Get the point? So what does that imply? It implies that distance over time is the formula for speed. And you all know from primary that from this you can derive a lot of things. What are those? Distance is speed times time. Time is distance over speed. And you need all these things in this very lecture. Okay, now I've said that speed is distance over time. You will need this so much. Again, time will be distance over speed. Then distance will be speed over time. But you should be sensitive about this S, because S means something else. And I'll tell you. This S, the S we are talking about here simply means speed. So it's better you actually maintain speed. Put their speed, put their speed. Yeah. So just something small, just something small, just something small as a note, which you'll also need, that distance, displacement, time, total time. We have those three. So here I want to put their letters. Yeah. So for distance, we shall always use what? D. But there is when they use L to mean length. Displacement, it is S. Basically that, S, nothing else. Time alone is small t. Total time taken, capital T, period. So when you find those things somewhere, have it in mind that those are the denotions they represent. Okay, that is done. So the SI mean here is speed, but S is already owned by displacement. Okay, so when I talk about velocity, velocity is the same as speed. I told you they are sisters, they are sister quantities. So velocity is speed, but speed in a specific direction. Just like we said, yeah. But we get the definition of speed, the students of physics know that we get it from the formula. We get it from the formula. Yeah. You're the ones who are going to do the examples. I'm not going to do any because you're claiming that the things are easy. Let's wait and see. Okay, so the distance always changes because when you're moving from Kampala to town, sorry, from town maybe to the village, the distance you're covering goes on increasing. It goes on changing as time is increasing. So the best word to put here to measure your speed, remember, for you to move from town to village, you're moving at a certain speed. What makes that speed to change is because the distance you're covering is changing as the time also changes. Yes, the distance you're covering is increasing, also the time you're covering is increasing. Yeah, that. So the best definition for speed, the next person that writes in the screen, I'm going to remove you. Yeah, I'm going to remove you. So, how to define speed, have it in mind. Change of distance over change in time. Or instead of change of time, I remember teaching you, and I'm not repeating it now, that change in time is the same as rate. Yes. So instead of you saying change of time, just say rate. Rate. How is it used? When you have x equaling to a over time, hope you are aware that you either say that x is changing a with respect to time, or you say that x is the rate of change of a. I've just said that and I'm not repeating because I'm not teaching you definitions. So x, you just write this in your books. You either say that x is the change in a with respect to time. I even taught you this in differentiation. Or you say that x is the rate of change. That every time you have anything, the moment you have anything over time, anything over time, it is the same as rate of that anything happening. Distance over time, it is the rate of that distance changing. Period. Okay. So, concerning speed, we said it is distance over time. So I'm taking you to velocity, then we do average velocity and we shall be done. So speed, we said it is distance over what? Time. So the moment I change this distance and I make it displacement, that means this time round, my distance is being covered in a specified direction. Then down I'm having my time like that. So the whole of this now becomes velocity. As simple as that. When you quote the wrong things, I've tried my level best to explain. So this is velocity. Then for speed, it is the one of distance over time. Velocity is that. So if you're defining velocity, you either say it is the change in displacement with respect to time, or you simply say it is the rate of change of displacement. In math, we don't define, but understand the formulae. But both of them, you like it or not, they are measured in what? Meters per second. And that is it. Those who want to take the screenshot, let me pinch the screen for you to take. And then we also take other things. And finally talk about average velocity. I'm interested in the word average velocity. Yes. So you can take that screenshot very fast. Okay, believe you're done. So when I'm back here, let's tick let's tick speed and velocity, they are done. So this is what we have, just the word average. Speed and velocity we are done. I just want to tell you about this average part. Very important concept. So when do we have this? When do we have the average speed and average velocity? It is easy. When you're moving from A to B, actually those who are saying that these things are easy and I'm wasting your time, who can tell us what average velocity is or average speed? Anyone among those who have been saying the work is easy, who can tell us average speed, average velocity? You just tell us a story about them or any question that comes and requires them. Anyone to brief us? Anyone to brief us? No one. Anyway, so I told you that when you're moving from A, let's say to B, then to C. Why I'm putting them in a straight line? To bring out what we are covering. Linear motion, motion in a straight line. Okay, so I told you that the time you need to move from A to B is T subscript AB. To move from B to C, it is T subscript BC. You understand? That is the time. For each of them, I want you to listen. Then, from here up to here, I remember telling you that distance is denoted by that letter. So it will be DAB. So D means distance and we are moving from A to what? To B. I'm teaching you the notion so that you can have very nice presentations of mechanics. Very nice presentations. So from B to C, the distance DB to C, that's what it means. And everyone knows that. So you all know that capital D, which is called total distance. So every time you do things of total and total, make the letter capital, total distance. Then if it is capital T, it is no longer time but total time taken. Or just total time. Those things of total time taken were things of primary, where we used to say total distance covered. Of course it has to be covered, nothing else. Then total time taken. Of course time is taken. What do you expect? So the total distance we'll have covered will be distance from A to B plus the distance from B to C. Then the total time you'll have taken is the time you used to move from A to B and the time you used to move from what? B to C. So they are different movement. You first move from A to B and then later from B to C. Maybe you use different speeds, whether the same speed, we don't care. But the moment these things come up, that's when the average stuff comes in. Hey. So you may be like distance over time was speed. But what if it is total time? We're having two different distances. So as we are calculating the distance over time, we shall be getting some sort of average. We shall be getting some sort of average. You should know that. So the moment you get the total distance, and for the physics students, it is worse. Should understand these things. Out of total time. So I've told you there are two different distances. It's like you getting two different marks, but they tell you we want only one mark. So they get the average mark. Yes. So because of distance over time, it is our speed. But because two distances were involved and we had total and total, it ceases from just being speed and it becomes average speed. So in the moment you see a question having like 3 points or 4 points, and the distances moved maybe by different people, something like that, it will always ask for average speed. So have it in mind, they want you to involve total things. Get the total of distances, get the total of the times, add them, divide, and so on. And after this, I'm not doing any examples because they are going to just be obvious, just as referring to what we said. Okay, now you may be like, what if the question asked for average velocity? This time round, not speed. And I already told you before that when you really want to get velocity from speed, just change only and only one thing. Don't change a lot of things. Only one thing. And what is that? Make distance a displacement. This distance in the formula, it should be a displacement. So the moment this becomes total displacement, of course time never changes because it is a scalar quantity. East or west, it remains with only size. It will never have direction. So for it will be kept as over total what? Total time. So this one will give us what? Average velocity. So the average thing has its reasoning on the total stuff. Total things like that. So you realize we are done. So whatever I've discussed is something you've been doing since primary. So let me hope, even it being a recap, you have at least learned something. So we only have one definition to go, and that is acceleration. Only this one. And after this, we are going to just look at how numbers are done. I'm not doing any numbers. You take screenshots, practice them on your own. We are going to expose the notes we are using for today, and you will see everything. So, acceleration. So at least you've heard of the acceleration due to gravity and everything. And I know you people have heard that the unit, you know the unit is meters per square second. At least you know the unit, that one I'm sure. But you all know, for you to say that the body is accelerating, you're trying to mean that its speed is increasing with respect to time. I think you know that. For one to say that a body is accelerating, that means its speed is increasing with respect to time. Because you're like, hey, in just 1 minute, the speed increased from 22. I don't know if you see that. You can be like, in just a minute, or let me say 1 minute, in just 1 minute, or 1 second, speed increased. That's when for you start saying, hey, that body is accelerating. Speed increased from maybe 4 meters per second to 20 meters per second. I think you see that. Especially, there is that thing of saying positive and negative acceleration. But negative acceleration is what they call deceleration, and we don't need that. So for you to say that the body is accelerating, or it's having a positive acceleration, that means you're looking at how its speed is increasing, but of course with respect to time. We shouldn't forget time. That's why we are having such a unit. So you need to know that meters per square second, this one came from meters per second over second. So it's like meters per second per second. That's what makes it that. So you all know that meters per second alone, it is for what? Velocity. Someone may be like, why aren't you saying speed? Why are you using speed here and then you're using velocity? You should understand that acceleration is a vector what? A vector quantity. So I'll go with velocity, which is also what? a vector quantity. So here I can just maybe add direction, any direction to make it a velocity. Or I can just remove this speed and put velocity. Instead of me adding a direction, I can just use the word velocity. So it is velocity over what? Time. But remember, it is not just one value of velocity. No, the velocity is actually what? Changing. Because we said in 1 minute it changed from or increased from 4 to 20. So if you're to define acceleration, you will say acceleration is the change in velocity with respect to time. If you don't say that, you say is the rate of change of velocity. I told you that anything over time is the rate of change of that something. Hope you get it. So that is the acceleration. But I want to tell you this. We said, or we've said, that speed, okay, we've said that velocity changed, we said from what? From 4 meters per second to, we said 20 meters per second in 1 minute. 1 minute is 60 seconds. Remember telling you it is better we have our time in seconds because even the speed is meters per what? Per second. I'm just using this information. This 1 minute is the 60 seconds. Let me use seconds. Some people may be disturbed. Let me say in 5 seconds, the speed increased from 4 to 20. Even here I say that we have said the speed changed from 4 to 20 in 5 and only 5 seconds. So this velocity it had at first, before it changed, it is our initial velocity. It is our initial. Now the real work has started. This one is the initial velocity. And it has a certain letter. You write that letter in the chart. Then this velocity it will get finally. It's called the final velocity. And the final velocity also has its letter. Also write it in the chart. Then you know that the 5 seconds, it is the time taken, and I already talked about it as small what? Small t. So what are those two letters of final and initial velocity? I'm seeing all of you failing because all of you are using capital letters. I don't know why. You people, you're scientists, you should rule your keyboards. It is small u and small v, not capital letters. Then the time is just that. So we have started the real work. Here you're supposed to listen. Whoever has been not listening, you're going to face it rough. So initial is u, final is v, the time is t. So we shall go back to our formula. I told you this velocity is changing. It's not just velocity. Just follow. I'm saying it all. Okay. So I'm going to come and say, but you tell me which letter is used to denote acceleration. You write it in the chat also, I see. So we said, acceleration is change in velocity. You write it in the chat, I see. So here we shall say that acceleration is denoted by oh, people have passed it, small a. Yeah. Then we shall see in the next lesson that we have what they call acceleration due to gravity, and for it is small g. Yeah. You all know that acceleration is the change in velocity over time. This student called Frank something. I saw that person saying, I feel like writing in the screen, and they have finally done that. Let me remove them. I think they can be. Let me remove them. Some people have. Let me not embarrass him. But I've removed him from the class. He cannot join back. Hide that stupidity. We are here for business. You say something in the chat and then you do it. I don't know. But sometimes you make us doubt some of your understanding, some of you, not all. Okay, so acceleration is change in velocity with respect to time, or the rate of change of velocity. So the change is easy. If you say that if you say that in 2020 the pen was costing 500, but right now in 2025 the pen is costing 800. This was the initial price. This was the what? This is now the final price. So if they ask you for the change in price of the pen, you'll be like 800 minus this, then you get 300. So it'll be like the price of the pen has increased by 300. And the 800 is the V, the 500 is the U. So as we are getting change in velocity, we shall also do what? Say final minus initial. And in most cases, that's what is done. Final minus initial. Final minus initial. So we are going to replace with letters. Yes, we are going to replace with letters. So we are going to have A for acceleration. The change will be V minus U over time. We have started. This is very important. Very important. That's the first formula. And we are going to use it so much. So I want you to listen. That is one. Before you even go into the equations of motion, look here. If a body has both u and v, you all know that u is the initial velocity. U is the initial velocity. U is the initial velocity, and then our V is the final one. Final velocity. You tell me, how can I get average velocity? Yes, how do I get average velocity? How do I get average velocity? You tell me, I want us to share. Remember, for us, we know that average velocity is total displacement over total time. But let's say a question has come, they have not provided us with total displacement, there is no total time. But what they have provided are velocities, both the initial, the U, and the final, the V. How can we get average velocity? It is easy. You people, they have given you the initial mark, and they also gave you the final mark. Then they are telling you, get us the final mark, or the average mark, sorry. You're given the initial mark. Let me hear from Ayob. Ayob, where are you? I cannot get you. Okay, yes, Ayob. How can I get average velocity with the initial and final? Let me open answers are in the chat. Yeah, I think people have tried. Yeah, thank you. That is it. That is it. Yeah. So that means you're going to enjoy motion. So for average velocity, you just get U plus V all over 2, like that. So you get both of them, divide by 2. If you get 50 and 50, 50 plus 50 over 2 is still 50. If you get 40 and 60 plus 100 over 2, average mark is 50. So it's all about like getting average or the mean. Yeah. So in case the examiner decides to confuse you and they ask you for the mean velocity, I don't want you to be that kind of student who won't be aware that mean velocity is the same as average velocity. So that is done. Now, so we're having our acceleration, we're having our initial velocities. Now, the other thing I want to talk about is constant acceleration, or the uniform one. But let me give people research. A research. Sketch. Sketch a well-labeled. Sketch a well-labeled. Yes, evidence.
Excuse me.
Yes, please.
Okay, I think I'm getting confused on this thing of like at first you showed that average velocity was total displacement over total time. And now
Yes, that
coming
is
down.
true.
Then now coming down, average velocity, we are getting the initial velocity plus the final velocity divided by 2.
Because questions come in different ways. There is a question that will give you the displacement and the time, and will ask for this, and it will not have given you the velocities. So you use the other one, which I explained well. But in case a question comes and it's only having initial and final, but again asking you for average, you just ask yourself, what if in midterm I got 40%, then in end of term I got 70%. Then they are like, the final mark we shall give you is your average mark. So this 40 was your initial mark, this was the final mark, or the later mark. To get average, you get 40 plus 70 over 2, isn't it? So you look at this as the English, not the math. This is English. That in average, we add and divide by 2. You get?
Yes.
Then the displacement, let it be the real math or the real mechanics. Then this one is just English. Add the 2, divide by 2.
Okay. Thank you.
Okay. Yeah, so the research is you go and sketch a well-labeled velocity time graph. Velocity time graph. Well-labeled. 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 You go and check UNEP 2024. 2023. I told you when I give you references of the old curriculum questions, don't feel bad because it is those questions that are turned into scenarios. So you need them first before you even start bothering yourself with scenarios so that you get the concepts. So it's UNEB 2024 paper 2 math. Of course, the subject is math. You cannot get it in chemistry. Yeah. Maybe to give you some sort of hint, I'm interested in the well-labeled part. Well-labeled part. I taught you under scatter diagrams, and I told you when they say velocity time, that means velocity is here. Then time is here. Velocity time. So I don't know how yours will look like, but whatever you draw for me. So by well-labeled, I want you to talk about point O, talk about OA, talk about point A, talk about AB, talk about point B, talk about BC, talk about point C, like that. That's what I mean. So it's like I want to know what happens at O, what happens during OA. So befriend a physics student. What happens at point A? What happens at point AB? Sorry, the distance AB. What happens at B? Then what happens along BC? And finally, what happens at point C? That's what the question wants. That is the hint. Yeah. Now, when I go back here, yes, La Loca. What do you want to say?
From OA.
So the acceleration, this one has also been covered. So that is all. So realize we have tried our level best and we have talked about all terminologies. So the next time they appear in our discussions, I will not repeat myself. I'll just ask you to refer to this lesson. I'll just ask you to refer to this lesson. Now we are going to derive the equations of motion. We are going to derive the equations of motion. Using them is very easy if you know what each means. Using them is very easy. So, equations of motion. Equations of motion. I want you to listen. Yes, Ayob.
Yes, sir. Does it mean that acceleration is a derivative of velocity with respect to time?
Exactly. Exactly. Just because that topic was removed, it was called vector mechanics, or it was called vector calculus. Yeah. But we shall not go into that. But that's a very good observation. Thank you for that. So people will say that acceleration is the rate of change of velocity, which is that. Isn't it? All of you know that. So what will happen if I cross multiply? When I cross multiply, I'll come up with AT equaling to V minus U. That's what I will have. Then when I make V the subject, I will have U plus AT. I don't know if you people can see that. Simple math. And this is the first equation of motion. That one is the first equation of motion. First equation of motion. Is that okay? Then from, we all know that average velocity is equal to total displacement over the total time taken. I want you to look here. I told you that average velocity alone, this one alone, is u plus v over 2, isn't it? We said that our time is a t, isn't it? And our displacement is always s. Not so? So when I come and write u plus v over 2 is equal to s over t. Are we together at that point? The first equation of motion was derived from the definition of acceleration, and all I did was to make v the subject. Then how are we going to derive the second? We are going to derive the second in a way of average velocity, being total displacement over time. Average velocity, we have just talked about that thing before I introduce the equations of motion. Time, you all know it is t. Total displacement, you know s is what denotes displacement. So are we together up to that point? We proceed with cross multiplying. Are we together up to that point? Yes, now we have started what projectiles wanted us to do. Projectiles wanted us to first review the equations of linear motion, but we couldn't do that unless we know average velocity. You cannot understand average velocity unless you know velocity. You cannot understand velocity unless you know speed. Hope you see why we are deriving all those things. You cannot understand total displacement unless you know distance. So you see why we are doing all that. So you weren't wasting time. So you people are saying we are together. So let me cross multiply and make, of course, s the subject. So when I cross multiply and make s the subject, s will be the side alone. The u plus v over 2 may stay alone, but we may have t here. Yes, we may have t there. We may have t there. So after putting a t there, I'm going to give this equation a name. I'm going to give it 3 stars. Hey, I'm going to give it 3 stars. Why? I'm going to use these 3 stars somewhere. Or you can just give it 1 star or 2 stars, whatever you want. Then you say from equation 1, v is u plus at. Not so? So because v is u plus at, I'm going to come and replace v with that. So I come and say s is equal to, I'll have my brackets, I'll have my u, I'll have my v, but my v I've said it is a u plus at, people can see that. Then all over my 2 is remaining, then square brackets, then my t. Why I've used square brackets? Because inside I've used the curved ones, and I explained that. Are we together? I don't want to leave anyone behind. So we proceed. I'll have my s here. Now inside I'm having 2u plus at. Of course, this u and this u gives me 2u. Then the at is alone over 2 into like that. And so then after that, I'm going to bring the t inside. What am I going to get? I'm going to get 2ut plus at t squared because the t's are now 2. Let me write my plus very well. Plus then this one over 2. Not so? Then I'll split. Something you need to recall here, I'm going to remind you. I want you to recall that x plus y over z is the same as x over z plus y over z. X over z is the same as y over z. I think you know that, eh? After splitting, they share the denominator. So I'm going to do the same thing here and split stuff. So I'm going to say that we're having s is equal to 2ut over 2 plus, this will be 8t squared over 2. Then I'll simplify and I will obtain the second equation of motion. Second equation of what? Of motion. So my s will be ut plus a half. Hope you're seeing the half. Then 80 squared. Like that. So the whole of this is the second equation of motion. It is the second equation of what? Second equation of motion. Hope we are at the same page. That one is the second what? Equation of motion. Okay. Now, what of the third? Because we all know the equations of motion are 3. Equations of motion are 3. So we have the first one from definition of acceleration. We have the second from average velocity. We are now going to have the third. So the third, I would say from equation 1, 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 you know A is equal to V. Okay, it's like that, equation 1. So I want us to make T the subject, yeah? So these ones can switch positions if you people know math. If you people know math well, these things can switch positions. I don't know if that is okay. If that's not okay with you, you can tell me, I repeat. So V, this over A. Those two can switch positions and you make T the subject. Because even when you first make it at T, you will again divide by A on both sides and you will have to get this. So I'm going to give this one 2 stars like that. Yeah. Then after giving that one 2 stars, you recall that we have 3 stars somewhere. So after getting my 2 stars, I'll substitute the 2 stars into the 3 stars. You're referring to the equation, eh? I didn't want to use equation 1 and 2 because they are the things I've been using. So I want you people to look at, you look at the 3 stars. You look at the 3 stars and the 2 stars because now I'm going to substitute. You look at the 3 stars. Do you see where they are on top? I don't know if the screen is clear. Look at the 2 and 3 stars. The 3 stars, it is V plus U over 2. Do you see that? The 3 stars, it is V plus U over over 2 then times T. The 2 stars, it is T equal to V minus U over A. Are you okay with both stars? Then we substitute. So we are substituting 2 into 3. 2 stars into 3 stars. Should we proceed? Do you see where T is in 3 stars? We are going to remove that T and put the V minus U over A. Are those 2 stars okay? Okay, we proceed. I like that. So we are going to come and say Um, so I'm going to rewrite the 3 stars. It was u plus v, but me I'm going to write u. It was u plus v, but me I'm writing v plus u. Same thing. Then I'm removing the t, and I'm putting this thing of v minus u. I'm putting the one of v minus u all over a. That's what I'm putting, like that. So, if you have a very keen eyesight, this one will be v plus u, this one will be v minus u. Who can tell me, what do you see on top? You tell me what you're seeing on top. How is it called, and what will it give us eventually? So 2 times a is 2a. You tell me, what do you see on top, the numerator? What do you see in the numerator? And how is it called, and what will it give us in the end? Yes, Glory. Yes, Glory.
It is the difference of two squares, and
It is the difference of... Mm-hmm.
it will give us v squared
Mm-hmm.
minus u squared.
Minus u squared. Thank you so much. Yeah. So those of you who don't know that it's called the difference of two squares, or if you don't know it condenses to that, in your free time, multiply them slowly and find yourself there. It will come out. So how it's becoming this, how this one is becoming this, do it in your free time. So it's also research for those who are not sure. Find out why that one is becoming that. I've given you the hint that it is a difference of what? Two squares. Now after that we shall cross multiply. Cross multiply. So we shall have 2as, then this side we shall have v squared minus what? U squared. So this minus u squared, it will go the other side with a plus, then we shall make v squared the subject. Then we have agreed that u squared is the other side with the 2as, like that. Why I didn't want us to start with reviewing the equations of motion straight away. I wanted, by the time we do the derivations or the review, when people know what each letter means. So this is the third equation of what? The third equation of motion. Yes. So you must know that I want someone to unmute. Who can unmute? Someone who has been following me from the first word. I want to ask you something, but I want you to raise up your hand first before I can ask, because we are done. The next thing is calculations. And thank you for listening for the 1.5 hours. Okay, Ben. Unmute Ben.
Yes,
Okay,
sir.
Ben. You tell me, what does V represent?
The final velocity.
The final velocity. Good. What does U represent?
The initial velocity.
The initial velocity. What does A represent?
The acceleration.
The acceleration. What does S represent?
The displacement.
The displacement. Thank you so much. You can now mute. Very good. But not all questions are going to tell you that it is displacement, but they will give you distance in a specified direction. So it's up to you to know that, oh, distance in a specified direction, that is the same as displacement, and you pass the question. Remember, they don't tell you which equation of motion to use. It is you to find out which one actually works. So even if, how do you know that it is the second that I would use? You just need to know that this is displacement or distance in a specified direction. This is initial velocity. This is time. This is acceleration. Then in the first one, you're having, where is it? It's here. You're having final velocity, you have initial velocity, you have acceleration and time. So it's up to you. Ask yourself, what do I have? And what does the question want? And which equation will work? So you need to know all the three at head. So you need to know what each letter denotes. and then you reason out all questions. So I think that is all with linear motion. Now, the next questions we are going to do are questions. Okay, the next thing are only questions. So we are done. Thank God we are done with linear motion. The next time we are coming back here, we shall be talking of projectile motion, vertical projection, horizontal projection, and so many things. So for today, the introduction has been successful. Trust me, the solutions are easy. And I may not even write anything, surprisingly. I may not. So let's go. Linear motion. So you can see motion in a straight line. Hope you're seeing my screen. And thank you for maintaining numbers above 100 up to this point. You know, if people are sober. Okay. Now, distance, length between two fixed points, that one was covered. Speed was defined, velocity was defined, the formulae were given. We don't have time to read, you read on your own. So you people, I'm going to be reading a question. You tell me it is okay. We go to the next thing because the solutions are here. So example 1, they are saying, find the distance traveled in 5 seconds. So the 5 seconds, this is what? Time. For a body moving at a constant speed of 3.2. Are you seeing that? And they are asking for distance. They have given you time and speed. Do you remember when I told you that you can get, I don't know, isn't this answer very clear? I don't want to explain. Constant speed is 3.2, time is 5, distance, primary work. That one is obvious. I just want you to always make sure that if the speed has been given to you in meters per second, make sure that even this time is in what? Seconds, and then you'll be good to go. And because speed is in meters per second, the distance will be in what? In meters. That is the only thing I can talk about. Otherwise, I believe the question is obvious. We proceed. Question 2. If a man runs 1500 or what you call 1.5k or 1500, 1500 meter race in 3 minutes and 3 seconds. Are you seeing? Things are becoming hard. They want you to get the average speed. Average speed. Average speed, the moment they say average, your formula should have total what? I think you can see the total things being included because they asked for average. And I explained that. So, they are saying, what was the distance? It was these meters. What was the total time? 3 minutes. Are you seeing? 3 minutes were converted into seconds and the 33 seconds were also added. They used the calculator and came up with this final answer in meters per second. Number 2, is it okay? We proceed. I'm not calculating. We are going through solutions because all has been said. We go. 2 is okay. Okay. We go to what? Number 3. Number 3, I want you to be serious. They are saying a man walks 150 meters due north. You tell me, what is that 150 meters due north? Is it distance or displacement? That 150 meters due north, is it distance or displacement? I just want to see one answer. It is displacement. Very good. So the 150 alone is the distance. But since they are specifying the direction that due north, that makes it a what? That makes it a what? A displacement. And they are saying that was done in a time of 70 seconds. And then, that was chapter 1. And then, 50 meters due south. 50 meters alone, it is a distance. But both of them combined, it is a displacement. And this happened in a time of 30 what? 30 seconds. They are asking for both average speed and average velocity. I told you both of them don't mind about time. Because time is scalar, so both of them it will be total time and total time. And because of this word average, because of this word average, both of them should have that keyword total in the formula. Total in the formula. The formula doesn't have marks in math too, but it has marks in physics. So you can do them or you leave things out. You people, you listen. This number is serious. So total time may be a bit easier for all of us because at first it was 70, then 30. You get? So to get total time, you add 70 plus 30, 70 plus 30 in both cases. You to listen. So when they ask average speed, the total distance, you just add the distances. Because distance is scalar, it doesn't have direction. Just get the 150, add it to 50, as you can see here. 150 was added to 50 to get 200. 70 plus 30, it was 100. 200 over 100, that's how they came up with the 2 meters per second. Why meters per second? The distance was in meters and the time was in seconds. But then there is something very weird here. Is the thing of displacement. I don't know if you people are going to get it, but please force yourself to get it. You have no option. This is just linear motion, but it can be set and you're off. They said, you look at that question. They are saying 150 meters due north. Eh? So we come due north, and it is 150 meters due north. Then they added and said 50 meters due south. 50 meters due south. Here they said this one was done for 70 what? Seconds. This one was done for 30 seconds. And they are asking for total displacement. Because we need to get average velocity, and average velocity on top, it has displacement. So we are supposed to subtract. If you people know forces, if they tell you that this is a body and it's having here on top 70 newtons and then here down it's having 30 newtons, you know what to do to get the resultant. You say 70 minus 30, and then you say the resultant force will be 40 newtons upwards. Why do you say 40 newtons upwards? Because the 70 was the greater value. So even the resultant force will be in that direction. You know, if people are understanding. So that is for forces, and you know about it already. You know about it already. So the resultant shall be 40 upward. So the same with these things of displacement, that if it is 150 meters due north, we are going to the north. And you are also going to the south, and it is 50 meters. Remember, for displacement, you must consider direction. So north and south are different directions. So the overall we shall have will be a difference. So the overall will be 100 meters due north. Because displacement has direction, so don't just ignore direction. But for speed, where we had to consider distance, just consider the size. 50 and 150, add them, get 200, divide by 100, get 2. But for displacement, you consider direction. If you're going 150 in north and 50 in south, the overall is 100 in north. So this is your displacement. Divide it by 100, you get 1. But it is still due what? Due north. So the question I want to ask you people, is this answer okay? Because here they said 100 minus what? 50. They got 1 and also added due north. Let's hear from Glory as people are commenting in the chat whether the answer is okay. Yes, Glory.
So I have a question.
Yes, ask.
Teacher,
Mm.
if because I've said that 50 meters due north, and then 150 meters due north and 50 meters due south. But if they say 50 meters due north and 50 meters west, what do you do then? You also subtract.
They cannot ask that. They can only
Okay.
ask for average speed, but they can't ask for displacement.
Okay.
They are supposed to give you opposite directions at least. Yeah. You get it?
Yes, Chi.
Good. Let me hear from evidence. Yes, evidence.
Oh, okay. So what if it was like 150 was in the south and then the 50 in the north?
So the answer would have due south.
Because the bigger thing was in the south, eh?
Yes. They are like forces. Where the bigger forces is where the bigger force faces is where the resultant will face.
Okay, thank you.
Okay. So that is it. Now we proceed to another number. I don't know what people are saying in the chat. I don't have a chat secretary. So you people, I think you see, other than us coming here and do numbers and still you don't understand, it is very bad. This number would be hard to get if it's what I started with. So always appreciate. Always appreciate and trust the process. What are people saying? The answer is okay. The answer is okay according to the way you have explained. It's okay. It's okay. It's okay. Thank you. Okay. I think we are good to go. So let's see number 4. Let's see number 4. Number 4, they are giving you 3 points, A, B, and C. And they are saying they are in order of a straight line because we are talking of linear motion or motion in a straight line. So we are going to first have our sketch, compare it with the solution. Let's first have our sketch. Let's first have our sketch for number 4. So they are telling us they have 3 points, A, B, and C. And if you recall, we had these points before. We also had them, so we are going to cheat. They are saying AB is 5 kilometers, BC is 4 kilometers. So I'll come from me up to here, 4 kilometers. From me up to the 5 kilometers, sorry, then BC is 4 kilometers. Isn't it? Then they are saying, hope you're following. They are saying that a man runs from A to B at 20 kilometers per hour. So the first one, we are having 20 kilometers per what? Per hour. Are you following? Then what do I have? Then they are saying, and then walks. The other one was running. So this one is walking from B to C at a speed of 8 kilometers per hour. This one is 8 kilometers per hour. Yeah. So you all know the units. That's why I told you about units. This is distance, of course. This one is also distance. This one is speed, and this is speed. So what are these people asking? First question, they want the total time taken to travel from A to C. Do you recall when I told you about total time? So when you see total time, you know they want the time here and then add it to the time here. This is the importance of the things I happen to do in the beginning. What will make most of you fail this question? You will want to add distance and also add the speed. And then you say total distance over total speed, which is very wrong. I've never said that. I told you that when they ask total time, it is a summation of the time of A to B and the time of B to C. That's what you're supposed to do. So you all know to get time, this is distance and this is speed. So you can just divide distance over speed. Then this one will give us our quarter hours. You get the thing? Then you also come here. You divide the distance over the speed. You also get here half hours. And this is mathematics. If it is physics, you're supposed to convert those hours to seconds because seconds are the what? Are the SI units. But you can also decide to do that. You can also decide to do SI units and be like a quarter an hour, those are 15 seconds. Isn't it? Then you'd be like half an hour. Those are what? Hey, you people know. Sorry, not 15 seconds. Not 15 seconds. There are 15 minutes and 30 minutes. So you can so what we have here is our time for what? For AB. Then what we have here is our time for BC. Isn't it? Don't mind about the kilometers. The kilometers cancel. So even if you do the conversions, they will disturb you. Because when you convert 5 kilometers to meters, you'll have to also convert 20 kilometers per hour to meters per second, which is hard. So the best thing is to leave kilometers and kilometers per hour so that the time you get is in hours. So your final answer, you can decide to either leave it in hours or convert it to what? To seconds. Hey. So now the total time taken, that is capital T. Come and get a quarter and add a half using your calculator and you get 3/4. So the answer is 3/4 hours. If you want, you can even write your answer in minutes. I taught you how to convert. But me, I can stop there because that's where I want to stop. Can't stop there. But there may be that person who wants to have their answer in minutes. If you want to have your answer in minutes, 1 hour has 60 minutes. What of 3/4 hours? You get your answer in what? In minutes. There is that person who wants to have their answer in seconds. You do the same thing. You'd be like, 1 hour 60 minutes. What of 3/4 hours? You get minutes. 1 minute has 60 seconds. You multiply again by what? By 60. Then you get your answer in what? In seconds. So I want to ask people in the chat. Someone wanted to say something. I don't know. They have given up. But is part A okay? Where they ask total time. Get time for AB, get time for BC, then add them. The person who really wanted to say something, the person is gone. But the people in the chat, is it okay? Yes, people have said it is. That is good. Okay. Then here they asked, here, you see what they asked? They then asked for the average speed. Yes. People remember average speed, we are having what? The total time. And average speed, what do you get? You get the total distance, which is 5 plus 4. Then you divide it by the total time and get the average speed. Is Roman 2 also okay? That is obvious. So next time you respect whatever we'll be going through. Is that okay? Average speed is also okay, isn't it? It's also okay. We proceed like that. So number 5 is yours. Number 5 is yours. Yes, this number 5, you can take a screenshot now and make research later. I'm not going to go through it because it's the same thing. Because I can see they're also talking of AB, they are talking of BC. You get, they are talking of the average speed. They are talking of the average speed for the whole journey. So you can reason, They are talking of B to C in a time of 4 seconds. They are now talking of returning to B, such things. So this one is your research. Please go through it and the answers are here. The answers are here. So when you get the answer that is there, you've passed. If you don't, you find out why. I'm not doing that. Yes, that is yours. Acceleration is the change in velocity over time. We defined that. Okay. Then uniform, I remember defining for you uniform. I gave it here as an assignment of labeling a well-labeled velocity time graph. These are the equations of motion derived, and we also derived them. You get the point? Then these are the ones of, this is the third, which we also derived. So you can see we are moving. So about the examples, these ones are easy. Let's first hear from Flash. Yes, Flash, what do you want to say before I can proceed?
Master, I want to screenshot the question 5.
Oh, question 5. It's
Yes.
there. After I post it in the group so that people can have a look.
Okay.
Okay, thank you.
Done.
Okay, sir. Okay, now let's go to this question. I want you to look here. They are saying that a car is initially at rest. When they say initially at rest, that means it is not moving. It is not moving. Initial at rest in math means that the initial velocity is a 0. And the unit we are using here is meters per second. You can see, so I'll say meters per second. So we have that. They are saying it is initially at rest at point O. So they are saying the car moves away from point O in a straight line, accelerating at this. So they're also giving us the value of acceleration, A, which is V, so which is this, like that. So they are saying, find how far the car is from A after 2 seconds. So on top of that, they are adding us time, which is what? Which is 2 seconds. You get? They're saying after 2 seconds. So the summary we are having is this one in purple. We have V, which is 0, A, which is 4, and T, which is 2. Just ensure that if acceleration is meters per second, even the time should be in seconds. So they are asking how far. Here they are saying how far it is from after 3 seconds. So here we shall just use our T as a 3 period, 3 seconds. Then they are asking how far. This one I'm going to explain it later at last. So when they say after 2 seconds, that is the time taken to cover the distance. It is our T. Then when they say after 3 seconds, the distance you've covered within 3 seconds. So the time is 3. So someone tell me, which letter are they asking for? They're asking how far. Are they asking for V? Are they asking for S? Are they asking for G? Are they asking for T? Are they asking for capital T, capital D, D? What are they asking for? They're asking how far the car is from or after 2 seconds. You tell me in the chat. You tell me in the chat, what are they asking for? I'm following. So one person has told us and it is correct. That is Gilbert. So I think you people, yeah, that is it. You know it. They're asking for S. So you people tell me, according to this, according to what you've just told me, we are having our U, we are having our T, we are having our A, and they are looking for S. Which equation of motion can you use? The equations are there. Which equation of motion can you use? Equation 1 cannot work because it doesn't have S. It is equation 2 and 3 that have S. But equation 3 may not work because it is having V. But equation 2 will work because to get S you need U and T and A, all of which we have. You get? I think you see why we derived and we forced ourselves to know what does each letter represent. So we are supposed to use, as you've said, we are supposed to use the what? The second. The second. A, the second. So this U is a 0. The time is a 2 first, then later a 3. The A is a 4. So you can even decide to write the formula UT plus a half GT squared. Sorry, A. Sorry for that, it is A. Then after that, you're supposed to substitute. So in mathematics, the most important thing is substituting. This is our number 1. So let me show you how you're actually supposed to do this number, so that people can get to know what I want. So you're supposed to come and say that your YU is a 0, put the unit, put that, then say your T is 2 seconds first, then the A, they gave us 4. No one marks this summary, so even if you first leave units. So we have agreed that it is the second that will work. You can write it or ignore it. They are there in the logbook. You can find them in the logbook. Yeah, someone with the logbook, you check. I'm not going to bring my logbook today because we are running out of time. Simply check the logbook, go under mathematical formulae, look for mechanics, look at where those 3 equations of motion are, tell me the page and the formula number, and tell me in the chat, page this, formula this, so that I just put everything. Okay, so after that we can come and substitute. U is a 0, T is a 2, this one is a half, A is a 4, T is 2 squared. So use a calculator, tell me the answer there. This was Roman 1, it was after 2 seconds. Then Roman 2, which was after 3 seconds, we said our T is a 3. So no need of rewriting the formula. No need of rewriting the formula. So you just come and substitute. The U doesn't change, it is a 0. The 3 is a T. A half remains. 4 does not change, but the time is a 3. And it is squared. Like that. So you also press the calculator at once, tell me what you get here. Also here, tell me what you get. We use the meters per second. So the distance we are getting in a specified direction should be in meters. So I don't know if my calculator is right, but here it's giving me 3 meters. Then here it's giving me 18. Let me see what people are saying in the chat. Page 65, what of the formula? Yes, it is page 65, but what is the formula number? Is the formula number 77? Okay, page 65, formula 77. Okay. So I shall just put here a note and say that equations of motion are in the logbook. But people are not easy. The lesson says, okay, it is page what? Page 65, formula 77. Page 65, formula 77, yeah. So you do that. Okay. Now, so I think you people have seen. Hope these values are correct because I'm going to use them for something important. So this distance was covered after 2 seconds. This one was covered after 18. Sorry, the 18 was covered after 3 seconds. So if I come and put here my time scale, and I'd be like, this is 0 seconds. I put here 1 second. I put here 2 seconds. I put here 3 seconds. You listen. They are telling us that after 2 seconds, the distance was 8 what? Meters. Then they are telling us after was 18 meters. So I want to ask people a certain question. Are you seeing from this period to that period? From 1 second to 2 seconds. Is it the first second or third second? You tell me. As we are counting, is that the first second or the this first second or the second second? You tell me that period. I've said 8 meters were covered by 2 seconds. Then 18 meters were covered in 3 seconds. You get? But I'm asking this one from 1 second to 2 seconds. What is the right English to use? Is it in the first second or in the second one? In the second, yeah. That is it. People are seeing it. So by the time it clocks 1 second, that means we have been in the region for first second. So this one is the first second. Then this one is the what? The second. Then this one is the third what? Third second. So after you understanding that, let's now read the question. The question is saying, find how far. The question is saying, find how far the car travels in the third second. Do you get it? In the third second. Who can tell us the answer from that sketch? They only want the distance in this third second. They want how far that car travels in only and only the third. But we realize from 0 seconds to 3 seconds it is 18. From 0 to 2 it is 8 meters. Then what of in the third second? What is the answer? 10. That is it. That is it. That is it. Just say 18 minus what? 8 and get your answer as 10 in meters. So you learn those things of third second, fourth second, fifth second. There is a tendency of bringing those things. So you can see we have passed. Provided you substitute well and everything becomes very easy. Everything becomes very what? Very easy. Now, you look at this. A particle is projected away from origin O with the initial velocity, this one. So this initial velocity is the U. The particle travels in a straight line and accelerates in a straight line at this. So this one is A. They are saying how far. Find how far the particle is from after 4 seconds. I think it is the same thing. Eh? We are going to use the second. It is here. The second was, just this time round, it is not from rest. The initial was 0.25, not a 0. So we get our answer. And because the speed was in meters per second, even the distance is in meters. Then after that, they're asking the distance traveled by the particle during the 4th second. During the 4th second. Now, this one is serious. That one is serious. Now, take a note. Take a note. Take a note. When you're having 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 6 seconds. That's where I'm going to stop. The distance you travel up to that point is called the distance covered in the first second. You understand? Or for 1 second. The distance you cover in 2 seconds is this. You denote it with what? S2. The distance you cover in 3 seconds, it is called what? S3, like that. The distance you cover in 4 seconds is called what? S4, like that. And you all know let me add others. Let me make it kind of congested so that whatever I want can fit. I want to give you lifetime mathematics. Lifetime mathematics. But if you attended series with me, this one is going to be easy for you. I talked about this when I was teaching series. So I'm saying you're having 0 seconds, having 1 second, having 2 seconds, you're having 3 seconds, you're having 4 seconds, you're having 5 seconds, you're having 6 seconds. So having this, the distance you cover for the first second, the distance you cover in 2 seconds, the distance you cover in 3 seconds, the distance you cover in 4 seconds, the distance you cover in 5 seconds, then the distance you cover in 6 seconds. You get the point? Should respect that. So the distance you cover in 1 second is S1. The one in 2 seconds, it is S2. 3 seconds, S3. 4 seconds, S4. Like that up to S6. Hope you're with me. S2, S3, S4, S5, S6, that is distance. But remember telling you that this one is what they call the first, second, then this one is the second, this one is the what? This one is the third, and the third second, then this one is the what? Fourth second, then this one is the fifth second, then this one is the what? Sixth second, like that. I don't know if people can realize that if you really want to get the distance covered in the first second, it is the same as the distance you cover in that very second, isn't it? But when you want to get the distance covered within the second, you're supposed to get the distance covered within. So, you're supposed to get the distance covered within 2 seconds minus the distance covered within what? 1 second. For you to get the distance covered only here in the third second, if you have eyes, you're supposed to get this distance this one, the one you cover in 3 seconds, and then subtract the distance you cover in 2 seconds to get that distance in the third, like that. Same thing, to get the distance you're covering in only the 4th second, you're supposed to get this distance you're covering in all the 4 seconds, and then subtract the distance you can cover in 3 seconds. Then to get that, only in the 5th second, you need all the distance you've covered up to what? Second 5, which is S5. And then subtract the distance you've covered up to the 4th second, which is S4. And with this, you get the distance covered in only and only the 5th what? Second, and so on and so forth. I don't know if people are using this sketch word and are getting what I mean. So getting the S1, S2, S3, S4 are easy because you just simply replace T with that value in the second equation of motion. That when I say S1, I mean it is 1 second. When I say S5, I mean there are 5 seconds. So when I replace 5 where there is still the second equation of motion, I will get the distance covered within 5 seconds. I don't know whether people get the difference of within 5 seconds and within the 5th second. Do you know the difference? And you get this formula I've put, these ones. Because questions are not going to be split. The question will come at once. The question will tell you find the distance we have covered in the 100th second. Yes, in the 100th second. That's what they will ask. So it's up to you to be aware. It's up to you to be aware. A case in point, if you know that you're using the second equation of motion, which is this plus a half at squared, and they ask you for s in the 100th second, s in the 100th second, it is very clear. Get the distance you cover in 100 seconds. How do you get it? By putting here 100. Then subtract the distance covered in 99 seconds. How do you do that? By putting here 100, 60 squared. So by putting here 99. As simple as that. Any questions concerning these things of anything second? To check if people have gotten it, you answer this, answer this, answer this. What should I do if at all they need the distance is in the 96th second? What do you do? What do you do? You write for me the formula. The distance, it is s what minus s what? You tell me. I've said it is 96th second. You write the formula in the chat. You write the formula in the chat. That thing is so common and students fail it so much. That's why I'm overemphasizing. 96 minus 95. So please don't forget. So you just get what do you cover in 96 seconds and what do you cover in 95 seconds, then subtract. How do you get S96? In this formula of S, you substitute 96 wherever there is T. How do you get S95? In this formula of S, if it's the one you've decided to use, put 95 wherever there is T, then subtract. By default, this will be bigger. And then you get the difference, which is the required distance. And then also this cascade of hours tries to get it out very well. Even this one tried its level best. So lesson wants to say something. Please say it, we proceed. Please say it, we proceed. Evidence. Yes, evidence.
I beg for a pardon on this part of the S96 and the S95 on how you substitute it to the formula.
Oh. Do you recall this one? You look here.
Yeah.
This number, here we had t equal to 2 in this one. But then here we had t equal to 3. So you can see here for 2 where there was t, we put 2. Where there was t, we put 2. Then for 3 where there was t, we put 3. And where there was t, we put 3. That's what I mean. Do you get the S96 minus S95 before I tell you about substitution?
Yes.
We good. Now, this S90, this 96 means we want the distance covered in 96 seconds. So 96 seconds are supposed to be substituted where there is time. Remember, these ones are seconds, and seconds mean time. So we are supposed to substitute them where there is time. You get? This 95, we are meaning time. Because they said 96 second. So you consider 95 to 96. Then you subtract as I explained. But remember, this is time. So we are supposed to substitute where there is t. You cannot put it where there is u. You cannot put it where there is a. Those are seconds, so it is time. What is exactly confusing you? Oh, where did you want us to put it? I think she's off. I don't know if she has gotten the point.
No, teacher, me, I thought, okay, I hadn't seen very well. Me, I thought that the thing was like this, where there is UT on the part of the T, we put 96, and then where there is 80 squared, on the T squared, we put the 95.
No. We put it in one formula because one formula gives us one distance and another formula gives us another distance. You
Okay.
get?
Mm.
So you cannot have the same formula having different values of time. That one can never happen. Now, which kind of distance are you getting? So in one formula, it should be one value of t.
Okay.
So when they ask for the fourth second, you should be aware that they need you to get S4 minus S3. So S3, you just simply put 3 where there is t in the second equation of motion, as you can see, 13. Then to get S4, you just put 4 wherever there is t in the second equation of motion. Then you get 7 point what? 7.5. Then they ask for the distance traveled in the fourth second. Remember, for us, we said this. You people, you look here. Are you seeing for us what we said? S4 minus S3. So when you say S4 minus S3, it's going to be 7.5 minus 13. So the answer we shall get will be a negative 5.5. But remember, the question wants distance. Distance is scalar. Never mind about the negative. Just have the positive. So the person who did this never bothered. The person knew distance cannot be a negative. So the person simply got the bigger value minus the smaller value. Do you get that? According to what I've explained, our answer would be a negative, which is okay, but that is displacement. The question wants distance. So even when you get a negative, you are supposed to conclude with a positive. Why conclude with a positive? Because distance does not have direction. It only has magnitude. So ignore the negative and conclude with the answer of 5 point what? 5.5. If they ask displacement, you just leave your answer with a negative because it is okay to have it like that. That one is done. That one is done. So the very last example for today, then I leave you. Yes. These are the ones you do them on your own. You practice. There are too many. So they are telling you at t equal to 0, a body is projected, the initial velocity is this. The body moves, the constant deceleration that. So one thing I want to talk about is deceleration. So if when they say deceleration, it is a negative, as you can see. Is that hard? I think you know that. Acceleration, we said, I don't know if people recall that, but I mentioned it when I was teaching. That acceleration, they either say acceleration, which is a positive, versus deceleration, which is the negative. So I was saying, someone had called, sorry. I was saying that for acceleration, then versus deceleration. That this one is usually positive, then deceleration is usually negative, but they can decide to use the word positive acceleration to mean that, or they can say negative acceleration. But have it in mind, negative acceleration is deceleration. Then the other one is just a positive. I think that is obvious. Yes, lesson, what do you want to say? You're not talking.
What I wanted. Hello,
Yes.
Master. Thanks for the lesson.
Yes,
What I
please.
wanted to inquire from you, could you help us with some scenarios for such questions?
Yes, don't worry. I will give you those things, but just know mechanics will not differ so much as far as scenarios are concerned. And one thing you're supposed to do, first learn these things. When you learn these things, do a lot of search. The scenarios will be easy. Still, when you don't have the basic content, scenarios will give you a time. But I will share, don't worry.
Okay, Master, thanks.
So you people, you're welcome. So U is 10 according to that question. Then A is negative because of the word deceleration. Then they are giving us T as 7. So you just come here and substitute because they want displacement, which is S. So use the second and substitute and get the answer. Simple as that. So here they are saying, how far does the body come to rest? Come to rest. And what time does it take to come to rest? You people, is that really hard?
No?
With that question, you're supposed to just interpret what have they asked. Remember, they have told you that the initial velocity is the U. I want you to look at this question. Problem, it is too congested, but you're going to understand by force. So they told you that the initial velocity is 10, so you're having this U here sorted. They are saying how far. When they ask how far, this is S. It's what they want, S. Does the body come to rest? So when they say come to rest finally, that means V is a 0. But remember, you've been provided with a constant deceleration, which is a 2. So you also have A as what? Negative 2. So you simply ask yourself, which equation of motion can help me get S? Which equation of motion can help me get S? When I have my U as 10, my V as 0, and my A as negative 2. Then you'd be like, huh? The third can help. The third is this one, V squared equal to U squared plus 2AS. Something like that. Then you'd be like, but the question asked how far. Why I chose this, they said to rest, so V is a 0. They said initially it was 10, which we have. They told us A is negative 2, so we have it. So we can get this S, which is the how far the question wants. So when I'm to make S the subject, I'll say V squared minus U squared over 2A. And this will be giving me the S. So you come and substitute here, you put here the 0. I don't see anything hard. Put here 0. Then you also come here, U, you put there a 10. Then you also come here where there is A and you put there negative 2. And then get your answer, the S. No, nothing hard there. So you look here, don't you see? Exactly what I've said is what was done here. And they got the answer as what? 25. But then they later asked for the time it takes it to come to rest. So the question now brought in time. So after getting this S, which was 25, so we assume that it was also obtained. Now they're asking for the value of T. We have the value of T in the first equation of motion. And we even mentioned it that T is V minus this over A. You're having your V, which is a 0. You're having your YU, which is a 10. You're having your A, which is negative 2. Can you really fail to find time? So that goes back to you knowing the formula and what each letter means. So when you read the question, find out what have they provided you with? What have they provided you with? And what do you have? What do they want? Which formula can help you use what you've been given to get what they want? Period. I don't really think we need to do a lot of numbers concerning this. I don't really think. I think you can see they used the same thing and they got 5 seconds. So all these numbers that are coming below, use the same thing. Use the same thing. Use the same thing. So these numbers, you reason them out and see the answer you will get. Why you will understand? Because look here, they used the third equation and I told you what each letter means. Even here they used the what? The third equation. And I told you what it means. So you take a screenshot of this number, go and reason. Why was that chosen? Why were those substitutions made? Why did they do all that? Find out on your own. In case you fail, post in the premium groups, consult from me, consult from teachers. Hope the screenshot is done. When I also come to number 5, I realize they first used the first equation of motion, they used the second equation of motion, and yeah, that was it. So I also believe when you reason, and they used of things of A, B, and B, C, things we've been doing. So I also believe when you go through question 5, you also take a screenshot, it will be okay and obvious. Because they are using equations, you know. In case you fail to understand, the groups are there. We go number 6. Still number 6. I can see things of A, B, and B, C, things I explained. And in both cases, they are using the what? The second equation of motion. It is here. Because I can see in both cases, they substituted for t squared or t squared. And they solved simultaneous equations. They formed the equation 1 and also formed the equation 2 and solved it simultaneously. And you people know how to solve simultaneous equations. Then here in Roman 2, they used the third. So trust me, the good thing these examples have solutions. You can read through, have your own analysis, then see if it fits in what the question wants you to know. So, hope you have also taken the screenshot of that. But you people, you first promise me that you're going to go through this work. Yeah, you first promise me that you're going to go through that work. Because if you don't, that will be up to you. But these are old numbers of UNEB, 1999. And why I'm not even doing all these numbers that have maybe more complex cases, because linear motion was not part of the syllabus. They just wanted you to review the equations, know what they mean and how they are used. And that's what we've done today. Yeah. But in all these questions, they are the equations of motion they have been using. Just because at one moment in time, quadratic equations come in, like here. And you know how quadratic equations are dealt with. So I don't expect you to have a lot of issues. First, promise me that you will find time and go through this work and you will understand. You people, for us to come up with the quadratic equation, that means we had this SUT plus a half AT squared. And guess what? We are looking for time, but we have S, U, and A. Do people see that? That when you substitute for S, U, and A, you form a quadratic equation in T. And I know you people know how to get quadratic equations. And quadratic equations give you two values. So when you get a positive and negative, time cannot be a negative. You go on with a what? A positive. And quadratic equations will always be there. Will always be there. Just wait for the moment you see things like t squared, v squared, u squared, just know that in case you're looking for one of those, a quadratic equation may or may not come, depending. And then lastly, you'll be handling the exercise. Hope you have also taken the screenshot of that number. So you people, you promise me in the chat that you're going to go through the numbers and make sure they make sense. But what I wanted is you to learn the terminologies, to learn how the equations of motion are derived, what each letter means in each equation, how they are used in basic numbers, then the complex numbers is you to go and make sure you make sense out of them. So take a screenshot of the first part of the exercise. Take that screenshot of the first part of the exercise. Hope you're done. Take the next part from there, number 49. Take that part also. In your free time, you practice. The answers are even there in brackets. You take that part also. Take that part also. So in the folder of e-library, you can find these notes. Yeah. On the drive. For those who don't want to use screenshots. Can take that part also. Can take that part. Yes, Flash.
Yes,
Take that.
yes, doctor. I've been asking about some videos.
Oh, you give me a call. I'm going to put my number at the end of the lesson. And that very number of mine is the one that receives payment. So you pay, you send me your email, I give you access to the drive. Then you go and enjoy.
Okay.
Yes.
But I've been saying that I have access to the drive, but just that the problem, I'm not seeing some videos of some topics that we
Those ones are
covered later.
supposed to be covered in
It's in
holiday
your
lively with us.
library with us.
Yes.
Shall we?
Yes, evidence.
So me who has no email, I can't get the work.
Yes, you can't.
Oh God.
But how a phone cannot work without the email. You check very well, it's there.
The mine is not there.
Then how have you accessed Zoom?
Miracles.
Okay. So you people, that is the end. You can see we have hit the target for today. I told you for today I just want what? Linear motion. Then next time we shall start vertical motion. This is vertical projection. You can see projected vertically downwards. Then we shall also see projected vertically upwards. So that's what they call vertical projection. So we shall have started something about projectiles. Something small, not much. That's where I shall begin from. And you realize that they will be the same equations of motion but interrupted with. But you had to first learn the real ones and how they work. I don't know if people have promised me in the chat that they are going to look through those numbers and make sure they make sense. If you lie to me, that is up to you. If you lie to me, that's up to you, but force your brain to understand those things. Otherwise, I sign out as Paul Tutor, Dr. Paul, a science math tutor at Science Scholars Academy, Uganda. Our offices are in California, USA. That's where my mentor is. Then my contact is this, and I prefer WhatsApp calls for early response, or you can text if you're patient enough. Otherwise, you start thanking me in the chat. Thank you for maintaining numbers beyond 50 up to the end. But I know around 30 people are sleeping, so I'm going to count the number of responses I see if really they are going to make 50. Whether people really follow or they don't. So you people, we shall start from there. Linear motion done. Next stop, vertical projection. Until projectile motion. So you people have been reading your messages. Yes, thank you for appreciating. Yeah. Okay, you people, bye. You find this lesson on the drive. Those without the drive, pay and access it. Bye bye.